Hi, Sportster Paul here with our second impression of SolidCAM, a CAM package computer-aided manufacturing that makes G-codes from your solid model to use in a milling machine or a lathe or what have you. Like last time, I said I had, well, not really love-hate, but like a love-exasperation experience, trying to get the part set up in the stock and the coordinate systems and all that. I got another little exasperation today practicing because remember, I warned you that if you open your solid file that you've got this SolidCAM into, you did an internal version. So the SolidCAM lives inside your solid part file. You open it, and then right away there's a little box that pops up. It says, open the CAM part. If you do that, and then don't do anything else, just close the file, it will update the file date, which could cause you a lot of configuration. You know, is that a newer file? What did I do? Why is its date suddenly different? This time, because as I make these videos, I take the file I start with and the file I end with and put it up on my website so you folks can download it. And this is a full version, so it's a trial version, not a demo version. So you can open them in your SolidCAM and look at what I'm doing. It got very exasperating. I said, well, let's save it as a copy, you know, the file from last session, and make it instead of session 1, session impression number 2. Wouldn't do it. It would say, oh, can't copy CAM data, or, you know, can't copy model, or something like that. And then the same problem is when I went to close it, it would update the file thing. So I figured out at least the way I think around it. I'm not sure this is the right way. As I say, there's this exasperation factor going on. But most of today is love because we're into the Toolpath. So bam, 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 we're going to probably get at least 3 Toolpaths done. So let's get going. Let's go up to SolidWorks. Big fun. So here it is. I might not even have gotten it ready. Add-ins. Yes, SolidCAM is enabled. I turned it off at startup, right? I wanted my SolidWorks to start empty. So then file, open. Here's the part from last time, -1. We're going to make it a -2. The way I found to fool SolidCAM into not messing up the files, now here, where it's asking, do you want to open the CAM part of this, the SolidCAM file, it's buried inside? You say no, you cancel it. Now you can say file, save as a copy and open, and change the name to whatever you want. I'm just going to make it a 2. Say save. It does its thing, thinks. Now it's asking you again, open this CAM part. Because SolidWorks, when it made the copy, it copied all the CAM data that they bury inside. They obeyed that. So now you say, yeah, copy it. And finally, here's where we left off. Meanwhile, even though we said, you know, usually now it prompts you close the old file, because of SolidCAM, it gets confused. You go to Windows, it didn't ask to close the old file, and it didn't close the old file. So here's the old file, I hope. Let's go up here. It's always good to look. Okay, here's the original. Remember, we didn't turn on the CAM part here, so we can just go to the corner and say close. And I think, boom, it closes. And here we are back. And it keeps pushing the tree off like Mastercam. So you got to do that, or use your Logitech gamer mouse where the scroll wheel goes left to right and does its thing. And always check. See, this is why it's a bit exasperating. You're always afraid you're doing something wrong. Okay, so we're in the right spot. Now, last time trying to get this little nag dialog box, upper coordinate system, you know, is upper level was above lower coordinate system upper level. I went and did something really stupid, which is I went into the coordinate system and changed where it thought the part was. Let's undo that and live with that little dialog box. I think I understand what it's trying to say now, and we can translate it. What do? See, this is where it's always a little bit of complication. Here's where I made it a 1/2 inch right here, upper part level. It should be -1/10 of an inch because we set part 0 here, the origin of this coordinate system, which we could get to if we go here, edit coordinate sys data. It's a 1/10 of an inch up on top of the stock, right? So where we changed it from -0.01, so let's change this to 0.1, put the minus sign in there. I think that's all we have to do. The lower level is correct, right? It's a 1-inch part, and since we're starting a 1/10 inch above, and then let's not touch anything here because that's dangerous, right? You confuse the program. It's picking defaults based on this, like it's guessing depths and stuff. Gets us here. All this is good for. There's nothing to do other than you can change the name here if you want. I don't know what I just did there. That scares me. Should we go look at it again? Edit. Yes, it took. Okay. Be careful what you click on. It thinks a lot. Now, once it said, hey, check your stock because the part moved. And it did. So, see, it keeps moving the tree over on us. Here we go. So here's where I don't understand this, why there's updated stock and regular stock. But here, and there's the stock where it belongs, where we want it. Now, because we did touch that coordinate system, it took our little checkbox off of our first operation where we faced the top. If you try to just say, where is it? Calculate. It's not regenerate for these folks. Does its thing, gives you the checkbox, but nothing happens when you check it. That's because because we confused it, right? This is nothing. I don't complain about this. I was the one that went in and hacked on this stuff. So you go in and look at levels and you'll see what happened. Since we moved it, it tried to preserve. Well, he moved that, so let's adjust this to make up for this clown moving it. Now, I learned the first thing, if you go 0.0, because the upper level is on top of the stock, right? This is where the cut is going to start. It doesn't like the minus sign, and it won't do anything. You got to take the minus sign off. -0 really gets it confused. Now it thinks, well, you must want to go down 0.6 of an inch. So this is all helping you. There's nothing unusual about this. You're really only going to go down 1/10. And then, because I love the way they don't poof the dialog box like Visual Mill, they leave it up. I hate the way they don't label anything. If you're using it every day, it's not a problem. Oh, the third one over is save, calculate with related operations. Not sure what that means, but it sounds comprehensive. So let's do that one. Say yes. Now this is what we messed with last time. Why does it give us this nag? I actually think you might be able to get away with don't ask again on this, but I'm not going to. There's our, and if you looked at that toolpath when we started this part, it was floating 1/10 of an inch in air. So that was a mistake, right? But we're back to normal. We're happy. If you want to simulate, you go here, click this, say yes, nag, nag, nag. There's our simulator. It shows you the different color here for the stock. I still can't quite figure out what the G does, what all of this stuff. It's nice though. So the dialog box comes back. Like I say, I always get worried. There in other programs, you hit close and you didn't close, you didn't save it. So I go down here, unlabeled, save and exit, nags again, and there. Okay, so this is our exasperation period, and that's the unfortunate thing. It always loads this exasperation at the front where it gets you really frustrated. So now let's go into the love part where you're just making toolpaths. Since you use this dialog box, you kind of remember what all those things on the bottom are. It's fresh in your mind. But see, here's my problem. I'm a non-machinist, never used SolidCAM where they picked up a lot of this stuff, and I'm an intermittent user. I do prototype work, so I might not use this program for 5 months and then come back to it and have some real intense session. So I worry about what I have to remember. Now, if I remember right, face top, click here, you get this huge dialog box with the triangle at the bottom, which I hate. What are we trying to do? We're trying to do a profile. We want to do the perimeter of the part. So you say profile, gives your thing. This is, the exasperate. Well, what do I do here? But since we've been doing this now, you kind of remember that'll let you define a coordinate system. This tells you what coordinate system you're doing. This is going to be something else to choose. You could probably choose the last one. No, they don't even have a last setup. So you go new. It lets you rename things, and I'm always big on perimeter. This is naming the contour, not the operation. That's a different thing. Then for the chain list, this is where I made a mistake, and this program taught me what I was doing wrong in SolidCAM. But I'm going to do it wrong just to show you how you can trip yourself up. Where you select this, and I've since seen videos where it's like, if you select here, it's going to decide to go in this direction. It'll go, looking from up, it would go counterclockwise. If you select it here, I believe, it'll go in the other direction. Well, to me, it just happened to be here. This was a convenient corner. It did its auto completion because this little enable chain direction which didn't work on the top, but works for this. It made okay to accept, say yes. And because our plane is 1/10 of an inch above, that's where the stock starts, that's where work 0 is. It puts, and we have this show chain on work plane over here. It shows, yeah, all around. But what I didn't notice, there's a little arrow here, and it's pointing in, that direction. It's pointing up, which means that's the direction of the cutter. And this is what, like I say, now I understand that why can't I just, this is the computer program. You know whether you're cutting stock or whether you're cutting solid model. Don't cut the solid model. General rule, right? Just make that rule. Then you don't have to ask us right or left, and we can just say climb. This way, you got to actually do a little mental, it's spinning this way, and for all I know, they'll reverse the spindle if there's some way to tell it, to force it to climb, but I don't think there is. Okay, so we named it what we want. We're out of here. Tool, another little exasperation. Visual Mill just leaves the last tool you used. It's only 2 clicks, select. There's only one tool, so this part was made. They have one tool and then 3 more for the holes in the bottom to center drill, and tap. So say that. Now it's got our thing. We made sure we got the right tool that's long enough to do this perimeter without choking. Level, see, this is why I went and corrected the coordinate system. Because this is where that data is what it looks to, right? It's a data structure. It's not just a coordinate system. That's where it makes its these intelligent guesses of what do you want to do. Well, you're already down 1/10 of an inch, and the geometry was on the bottom. So it's kind of saying, well, we'll start there, and since the geometry was at the bottom, we're going to guess you want to go 1 inch down. Nice try, but actually I want to go a little further than 1 inch, because when we flip it over and deck the other side, I don't want a razor sharp edge there, because, tiny little 10,000th of an inch in accuracy. So I want to go 20 thousandths extra. That's easy, 0.02. Okay, so now we're going deep enough. See, and this is where I always get turned around. Now, where do I want to go multiple cuts down? See, it's different and different, whether it's a pocket or a profile. Different programmers did it different. How did you do this? This is where I screwed up. See, left, the toolpath will be on the wrong side. But let's get the other stuff fixed. Here it is, rough step down. And it remembered from when I was practicing earlier today, 0.125. I want to go down 1/8 of an inch. So now it'll go down in steps. It won't do it all in one. And I want to go clear the offset so it picks the corner of the stock. First off, it's kind of a heavy cut because it's like a full width cut. So I want to do 2 passes around the outside. All these programs are a little similar, but you got to know down in this corner, click clear offset and go 0.125, and the step over 0.125. Now, thank you for not dismissing the dialog box. We'll do that. Now it has a different nag. Oh, you're below. And so this experience kind of made me think, being a professional technical writer, what they really want to say is the depth of the cutting operation is below the coordinate system part lower level. Okay? And so that's I'm a little more yeah, we probably can dismiss this. But it annoys me so much, I'm going to let it annoy us. Now, because I didn't understand about it has a direction and left, right. Well, I said left up here. See, it still says left. And so it put it inside the part. Oh, okay. So I said right. I'm kind of recreating my stupidity earlier sessions. Recalculate. Depth is lower. Nag me again. But that's what I want. You need these 2 whacks so you get the corner of the stock. You don't leave little pillars on the corner, stuff like that. Okay, and I think it's not too hard to see. It is 20 thousandths lower. And of course, that nag is reminding us. So what was it? I guess it was the simulation that taught me. And this isn't the full cool simulator that I love in this. Depth is below. It puts you in the coordinate thing, and you do this, and it's like, oh, okay. And it was just watching this, just a coincidence. It's like, wait a minute. If it's doing clockwise from above rotations of the spindle, and it's going in this direction, that's conventional milling. That's not climb milling. And like my buddy Dave, who designed this part to trip up cam system, said, why would you ever conventional mill? And there are reasons. It might be rip stuff out of the vise or, do stuff. But in general, surface finish, all this good stuff. So we'll close the simulator. Now I realize, okay, go back. Now this is lit up, right? The edit. You want to see the whole box? Probably better practice to show the whole box. Oh, okay. I want to go edit. the one that I labeled perimeter. See, let's go edit that. And then now we're back to that little bit of exasperation. Okay, I want to change. Well, I realized, oh, there's an arrow, there's a direction, a big epiphany. And I did all the Mastercam videos wrong. I didn't realize this when I did the Mastercam first, second, third, fourth impressions. There's a little arrowhead there. Okay, cool. I get it now, right? So you first you go here, and now it wants you to rename. I wish it worked like that in the tree. You go there, and you hover, because you get nothing's labeled ever in this program, the Steve Jobs school of let's not use text anywhere. Change direction. It won't let me do it. Reverse. It won't let me do it. You got to, after a lot of grief, figure out, oh, edit. Then it nags you. Do you really want to edit? Passive aggressive. Do you really want to edit? Yeah. You would think change direction would be what you want to do. I click on it. I don't know what I'm doing, but it ain't what I want. The arrow is pointing in the same direction. What you really want, what I really want, is reverse. And now you see it went to the other corner, and this thing will go. Now, I will spare you. I guess we say okay here. Okay to accept. Yeah. A lot of the silliness of, well, since I did that, now I got to go back to left. I won't, embarrass myself showing, oh yeah, I flipped the direction. Now it'll be cutting the model again. So doing that and saying recalculate here, depth is below. Yeah. That's what we want. And I was a little worried at first that is the end mill coming down on the stock and plunging into it. Turns out it isn't. And it took a few simulations. And that's why simulation is so important to me, because I am an amateur. I am a novice learning this stuff. When I did play around, it's not too hard. You tangent extension, you can make this, a couple tenths of an inch, and then you're sure that the tool isn't coming down on the stock, that it's always entering from the side, because plunging can be a little hard on it's a more difficult operation on the tool. See, now I may have done something wrong. I'm not sure. Let's do the cool simulator. This simulator is so fantastic. I don't have the compare function on. F sub x, right? Software people. Okay. There it is. Everything looks hunky-dory. We say compare now. It does have these, it is in beta, right? When you invoke this, there's a thing, parentheses, beta, like they're still trying. And it has this translucency that causes these artifacts that you see up here. But as you move things around, you can kind of tell, oh, sweet. The facing, and that's within plus or minus, I think, 1/1000th of an inch. Yeah, there it is right here. The green means you're within 1/1000th. 2/1000th. You're in plus 1/1000th, minus 1/1000th. And I'm pretty sure there's a way you can adjust these if you want to tighten them up. But that's sweet, right? We're dead on here. We're dead on there. And this simulator is big love, right? This is what really, really, really impressed me. The simulators that work like this, SolidWorks CAM by CAMWorks has this style of simulator. Visual Mill has this style of simulator. I don't know who's copying who or whatever. BobCAD and Mastercam have the ModuleWorks simulator. They're identical, essentially, although I think it's only the BobCAD that works backwards. The zoom wheel and the pan are different than SolidWorks zoom and pan, which can be pretty exasperating. So having the simulator, to me, is really a big deal. And this did a beautiful job. When I got to the holes and did taps, I could make sure the tap wasn't bottoming in the tap drill hole. Big deal. So we can, and here's like settings. Oh, I just flashed it out. Flyout window, right? So you can have it fill or not. This is all your directions, kind of like the SolidWorks thing. Fantastic. Fantastic. Now we're into the love, right? And we kind of reminded ourselves, fixing up the first one and the second. The little checkbox like Mastercam hides the toolpaths. Come on. I am in so much trouble getting orientations. There we go. And now this thing works. So it's kind of like in the vise like this, right? That's why I like working on it like this. So I kind of get used to how would it look sitting in the machine when I'm in the vise. So we did our perimeter. How are we doing? 19 minutes. Let's see in 10 more minutes we can knock out 2 operations. Add milling operation, pocket. Okay, so we've kind of learned you always start here at this unlabeled little gray thing, gray on gray, Steve Jobs approved. Oh, give it a profile name. This will be deep pocket. Do this. Come over here, give this a name, deep pocket. And then now we're a little bit of exasperation with Visual Mill and I think some of the others. If you highlight this, oh, well, let's do it. See how it completed the chain? No, don't accept it. Go away, go away. I don't know, go there. Okay. Uncheck enable direction suggestions. Don't help me. But most of them, you could go here and say select tangency. And if you do that, it gets about to here and about to here before for some reason it gives up. But at least it selects a whole bunch of stuff. And then the same thing you can do down here. Not so here. If you say select tangency, it freaks out. Oh, there's a gap because it's down here somewhere. Oh, it won't let me get it. Okay. Down here, there's some kind of gap thing. Is it here? No. Here it is, down way at the bottom. Gap options, right? They're trying to help you so you don't have an open path. Now, I prefer SolidWorks CAM by CAMWorks that just fills in as you keep clicking things. It draws a vector and a dark blue to show, yeah, it's a closed path. You're still doing a closed path. Here, minor exasperation, you're going to have to pick everything individually by hand. That's life. Not the end of the world, right? And it can help you. Matter of fact, I will purposefully show how this gap business, it giveth and it taketh away. Go do this one. Oop, come on. Hang on, you're under the headshot, Paul. You're not going to see that. Okay, then do this. Oops, nope. That was enough. It's got to be a corner. Go here. And see, this is where it helps. If you don't see that there's this little segment right there, you'll go here. And it says, do you want to close the gap? Well, you don't because they'll probably use a straight line. Don't close the gap. Nice that you asked. Get up a little closer and you can see what you're doing. There. See, now it did its thing. Now we can do this one. Now we can go back, do this one. I do like it projects up, and it's just a coincidence that I picked the plane, the stock plane, you know, where this is working is up a little higher. Now it knows it's got to close. It won't fill it in dark blue like SolidWorks, but it says okay to accept. Yeah, please do. I think we're done. We gave it a name, didn't we? Well, maybe. Oh, yeah, we got to go up here. Deep pocket. Everything's happy. I don't think there's anything else to do. And this has a direction too. For some reason, I guess maybe it just lucked out that it's going to do the right direction. But there may be ways. Say tool, a little exasperating. Why do you make me select it? Just use the last one. It's only, oops, see. Then you click something wrong and you... Levels. It knows it's starting a 1/10 of an inch down from the stock plane because we already decked a 1/10. It doesn't know what to do here. How deep do you want this? That geometry, even though it was on 2 levels, some programs would guess, well, the lower level is the depth. But this is like Visual Mill. Just, I got to make sure you can see this. Just click there, baby. Wow, look at this. How cool. 0.625. And that's not a coordinate down from the plane. That is a depth of the pocket from this point. So you're already down a 1/10 of an inch from 0, 0, 0. And now you go down another 625. We know that's right. Here is where you put step downy stuff, right? Multiple levels, 125. All this is how the tool pulls out technology. This is where you say contour. For a while, it started defaulting to hatch. Contour, this is where you say climb, right? I don't know, nested, I mean, geez, so many dialogues. All these programs have this problem. Tool diameter, 50%, so its step over is 1/8 of an inch because it's a 1/4 inch tool. Let's see, I think this is it. Complete Z level. Yeah, over here, because everybody wants to leave stock like you're doing a roughing. No, I want this to be mathematical. Swall finish. Let me get it out of your way. Here we go. I think this is ready. I think. You're never sure. So if we do this, you know, our calculate with all related operations, there they are. Like MasterCAM, beautiful toolpath. It spirals down inside, does it all around. So we're pretty happy with that. Oh, you might actually get all 3 toolpaths. So yeah, this is save and copy. So if you were going to do this again, like if you're doing holes, right, and you're going to center drill, and tap, well, you could save and copy, and it saves you. I just prefer doing them from scratch, but that's okay. So here we are. Hide the toolpath. Let's do a quick super simulation. Magnifico simulation. Here. See, and it's showing us the stock condition. So it screwed up once where it showed a mistake I made where I moved like from the inside of the part to the outside part on that profile. And that took going direction back and forth, and it kind of healed and knew where it was. But here we are. And it's got that little artifact problem where the translucency of the material, and I couldn't see a way here in all the stuff to like, well, I just want to make that 100%. That's okay. It's still fantastic. You go here, ooh, we're green everywhere. We're green on top of the plateau. We're green on the sidewalls, green in the corner. The perimeter's green. The face is green. Fantastic. This is a big deal to me, the novice. I have confidence now when I make G-code. So we get out of this. And now we'll show you a trick that my buddy Dave, the guy who invented this part to trip up CAM systems, more the automatic feature recognition. Notice I haven't saved anything. Of course, it's a stable program, unlike some others. It's been very stable. So I'm going to make a point with this. So add milling operation. We're going to do another pocket. Here's all the eye machining stuff, which they're so proud of, which is little wax and no hard corners. And that's a big deal, but we're not doing that kind of high-speed adaptive. Different companies call it different stuff. Okay, we're going to do the lower pocket now. Clock is ticking. First thing you know, after you do this a few times, you remember, okay, let's call it the shallow pocket. And let's click on the unlabeled mystery button. And let's remember, right? This is what bothers me. Will I remember all this? Unclick that so it doesn't go all the way around. And then you're going to love this. My buddy Dave showed me. Because I used to make a sketch. Because the problem with this is this hole bridges. And so if you just use use the bottom of the pocket as the driving geometry, the end mill will go around this and leave some stock up on the top. This way, wait till you see this. This is fantastic. I owe my buddy Dave for showing me this. He took pity on me when I was doing it because he's a Mastercam pro. He took pity on me and did the part and sent me the Mastercam file. And I'm like, sent me the SolidWorks file with the Mastercam stuff in it. And then I examined it and said, oh my gosh, this is so clever. You don't have to make a sketch to do this. On some programs you might. Mastercam works like this. I checked Visual Mill works. I haven't this is Windows 10. I upgraded to Windows 10 because of Wi-Fi City Hall. And here's what he did. You go down, do this little one, come back up. Notice no gap complaining. Everything's happy. Oops, I missed it. I missed it again. Here, go all the way around. Now the tool will try to get in this hole. It can't because it's a 1/4 inch tool at actually a 0.201 tap drill hole. But it'll try and put a little divot in the tool path, but it won't gouge anything or leave any excess. Whereas before, if it goes around here based on the face selected, it leaves a little meat here and a little because end mill can't get in there. All right, where are we? We're right here. Oops, not there. There. Then you go down to the floor, go across. If your coordination comes back, I'm getting a little bit weary. So here, and close it. And closed contour, it's happy. This is a good thing, right? They're like, I don't think I would dismiss this, even though you can. Okay to accept? Yes. It's got a chain. Oh, I didn't rename this one. See, I can remember all this when I do it over and over, day after day, like I've been. But if I haven't used this program in a month, I'm not sure. I think all this is set. You say, okay. Tool, once again, why, it's only 2 clicks, but geez, folks, levels. Here, see, now here's where all the programs get a little confused because the geometry was up on the top. It says, well, you must want to start up there. So for the upper level, and this is like Visual Mill, I love it. You just click there, it knows. See, now this is the coordinate, 0.725 down. So you go there, and sure enough, 0.725 down. Pocket depth, you can pick a point. Visual Mill, I think, requires you to pick a point. 0.85 down. I think this is all going to work out. It better. Yeah. And now this is depth, right? It's not a coordinate from the plane. This is, you're going to go 0.125 more than this point. So that's all happy. Technology, contour. See, some of the stuff it remembers. Other stuff like that, complete the chain, it defaults to something. Never the way you want, but that's just, you can't complain. Go to contour, climb, that's right. Oh, technology, finish wall, floor, 0, complete. Because I want to go all the way down in one whack. It's only a 125 deep. I'll just do that in one. Some of the shows I've been doing 2, 1/10 of an inch and a 1/10 and 0.25. I think we're ready. And I pull it off so you can see the toolpath appear. Very satisfying. Strongly recommend multiple monitors. Once again, a good looking toolpath. Going up here, and you should know certainly for 3D toolpaths, Modulworks, the company that makes the simulator for Mastercam and BobCAD, they also make the toolpath kernel, if you will, like the Parasolid and the ASYS kernel for CAD. And a lot of these programs, certainly when doing 3D, they're just manipulating and getting the data that package needs. They send it to Modulworks package, not anywhere else. It's inside the program, right? It's local. And then that responds back with the toolpaths. So all of these programs might have the same engine underneath them. I guess that's it, right? Why even simulate? Let's just get out of this. Because we're at 31 minutes. And we want to get done with this. So you unclick it. Once again, it moves over. So move that. All the toolpaths, none of the toolpaths. Here, shallow pocket. Use their new cool simulator beta. It's showing correct stock. You go here, off it goes. Done. Say compare. And just what you want to see. No discontinuity between the deep pocket and the shallow pocket, right? Everything's green. Everything's happy. It got around here. It went in here. Fantastic. This simulator is to die for. So what did I do wrong? There we go. So get out of the simulator, and it should be fairly self-evident if you go all the way up here and right-click and say simulator, then it starts from the beginning stock, right? And you can watch the whole thing do its, well, that was a little too fast. You can watch the whole thing do its thing, right? From the beginning. Same thing, I should probably turn this so it's kind of like it's sitting in the mill, and that'll get me used to what it's going to look like as it does its thing. All the way it goes, down to the bottom. Okay, so we're done. Next, we're going to have to do this flat. Unlike all the other programs, this is the only program that let me pick this point and do a contour. I didn't have to draw a sketch. It's the only program. But, give, take. They clutter your part tree here with this business. And this is where they make that stock box, which I hid last show. You can show it. You can hide it. But notice now, okay, we'll go back to SolidCAM. Here's all our operations. You can tuck everything up, be nice. I guess you can probably go all the way up. I guess that's as tight as it gets. Now, I didn't save it at once, right? Now I'm going to go up here and just close. And usually you're prompted, right? Let's see what happens. I hear my hard drive. Gone. File is, I can tell because I got a free commander over here on the right. Yep, it's the original file stayed 2 days ago when I made it. This file is right now, exactly 6 o'clock. So, is that a bug or a feature? There's a lot of thinking to do. Does this bother me enough for configuration management disasters? Or is this really a cool thing? And once you understand, well, just don't open the part, save it as anything you want, because I tend to do that, right? Because I am not just a novice machinist, I'm a novice engine designer, and I'm working on this SolidWorks motorcycle engine. And so I start something and say, okay, I'll just throw all that away. So it's good to understand this. Maybe to address these issues, that's why they did this whole external file business. So bless their hearts, a great company, support's fantastic, all these videos, their website's fantastic. So like I say, you got to get over the exasperations, and as I get more familiar with it the next few days, we'll do those flats, we'll do the slopes, we'll flip it over, do the other stuff, show you how good that simulator works. Meanwhile, hope you're doing okay, enjoy your CAM project, and we'll catch you in a bit. Bye now.